This is Physics Chapter 2, Problem 62. And it says, does a real automobile have constant acceleration? Measure data for a Porsche 944 Turbo at maximum acceleration are shown in the table, which is here. And then part A says, convert the velocities to meters per second and then make a graph of velocity versus time. Based on your graph, is acceleration constant? Explain. So we have to convert all of these to meters per second, and I just converted 1 mile per hour, which is 0.45 meters per second. So we can just multiply all of these by 0.45. So we multiply 41 miles per hour multiplied by 0.45 meters per second, and that gives us 18.5 meters per second, and then 66 times 0.45 gives us 29.7 meters per second, and then 83 times 0.45 gives us 37.35 meters per second, and then 97 multiplied by 0.45 gives us 43.7 meters per second, and 110 multiplied by 0.45 gives us 49.5 meters per second. And then the second half asks us to make a graph, which I already did. Here. And then it says, based on your graph, is the acceleration constant? Explain. And no, you can see from the graph here that acceleration is not constant, because acceleration is the slope of a velocity versus time graph, and this is not a linear line, so the slope is changing, so acceleration is not constant. And then part B says, estimate how far the car traveled in the first 10 seconds. So to do this, the area under the velocity versus the time graph gives us the gives us how far the car traveled. And so I separated it into 3 parts. So the first part we do is this triangle, and the area is 1/2 times base times height. So we do 1/2 multiplied by 2 seconds by 18.5 meters per second, and we get 18.5. And then for this one, it's just length times width. So it's 8 seconds multiplied by 18.5. That gives me 146.4 meters. Then for this one, it's 1/2 times base times height again. So I did 1/2 times 8 seconds times, and then the displacement there is 30.9 meters per second, and you get 123.6. When you add all these together, you get it traveled roughly 300 meters. And so that's part B. And then part C asks, draw a smooth curve through the points on your graph, then use your graph to estimate the car's acceleration at 2 seconds and 8 seconds. Give your answers in SI units. Hint, remember that acceleration is the slope of the velocity graph. And so, part C, acceleration is change in velocity over change in time. So 2 seconds, we do 18.5 minus 0 over 2, and that gives us 9.25 meters per second squared. So that's the acceleration at 2 seconds. And then the acceleration at 8 seconds is 43.7 meters per second. And then again, minus 0 over 8 seconds. That gives us roughly 4.19 meters per second squared.